Today, we will use the converse of Pythagoras' theorem to classify triangles as right-angled or otherwise, and we'll also look at something called Pythagorean triples. So what is the converse of Pythagoras' theorem? Well, that's like saying the opposite, so the backwards way of saying Pythagoras' theorem. So what we originally had was that if I have a right-angled triangle, then I have an equation that looks something like a squared plus b squared is equal to c squared. What the converse is saying, however, it's that, well, I could go the other way around. If I have sides of a triangle that are a, b, and c, where a squared plus b squared is equal to c squared, well, then the triangle must be right-angled. All right, so it's the going in reverse of the theorem that we used for Pythagoras. On the other hand, or another way of saying this is that if you have a set of positive numbers, so integers is numbers, right, whole numbers. So if you have three whole numbers, a, b, and c, we call that a Pythagorean triple if it obeys the rule a squared plus b squared is equal to c squared. So if you have three sides of a triangle and it's a right-angled triangle, we call it a Pythagorean triple. So let's have a look at some examples. So consider the following triangles with side lengths 3, 4, and 5. So let's see if they all match up using our Pythagoras theorem equation. So the very first thing we probably want to think about is, well, what side is going to be C? So whenever you draw a triangle, a right-angled triangle, your hypotenuse is always going to be the longest side, right, without a doubt. So in all of these, the ones which is the biggest number, that's going to be your C value. All right, so we're going to now see if our two smaller numbers, when we square them individually and you add them up, do they give us the square of our bigger number? So we have 3 squared plus 4 squared. That's equal to 9 plus 16, which is equal to 25. Now, what's 5 squared? That's 25. So that means yes, right? We have that 3, 4, and 5 are Pythagorean triples. So that's good to know. Next one, let's have a look and see if 6 squared plus 8 squared is going to be equal to 10 squared. So we have 6 squared plus 8 squared is equal to, so we got 6 squared is 36, and then we have 8 squared is 64, and if we add them up together we get 100. Now 100 is 10 squared. So we have another one. Alright, so another Pythagorean triple. Alright, I'm just going to write it like that. Alright, so if I was to draw one of these things, what that means is that I have a right-angled triangle and I know that my two legs are my two smaller numbers, so I could have a 6 and an 8 here, and I also have a 10 on the other side. So I know that a triangle exists like that. Alright, and it's definitely right-angled. Right, same goes with the 3, 4, and 5. That's saying my two legs are 3 and 4, and my hypotenuse is 5. Let's have a look at our next one now. So we have 5 squared plus 8 squared is equal to 25 plus our 64. Right, and that is equal to 89. Right, 13 squared is 169. Right, so they do not match. They are not a triple. So that means I cannot write or draw a triangle where I have the sides 5 and 8 and my hypotenuse is 13. That doesn't exist. Now, in terms of answering the questions at the bottom, which of the triangles are right-angled? We have A and we have B, right? Because we had 3 squared plus 4 squared was equal to our third number squared. Same with part B, right? C, however, did not have 5 squared plus 8 squared was equal to 13 squared, so it was not right-angled. On the other hand, which of them are Pythagorean triples? Well, we have that, again, A was a Pythagorean triple because 3 squared plus 4 squared equaled 5 squared, and likewise for B. Hopefully that helped.